Okay, so y equals c of x, where c has to be greater than 0, which is true. Describe how the graph of the second function compares to the graph of the first function. So your bases, like I said to you yesterday, your bases have to be the same in order to compare graphs. Okay, this is like right after yesterday's notes. It's the next lesson, the next page. So the only reason why we can compare these is this has a base 4 and this has a base 4. The base 4 doesn't tell me anything other than that it's increasing or decreasing. But if they're not the same base, you can't compare a graph. Like one is 4 and one is 72, it's like, no, ain't happening. Okay? Now, if it's with the x and the exponent, it is horizontal stretch, reflection in the y, horizontal translation. If it's in front of the base, it's a vertical stretch or a reflection in the x-axis. If it's at the back by itself, it's a vertical translation. Okay? So if it's with the x, it just affects the x, just like before. If it's in front of the base or at the back, it's vertical, just like it was before. Nothing different, other than the fact that the bases have to be the same or you can't compare them. So remember, when we compare graphs, we always compare what has changed. So sometimes, like for example, if this was 4 to the x minus 2, and then this was 4 to the x minus 2, the only thing that would have changed would have been the 2. So I wouldn't say it was horizontally translated 2 to the right in that case, because that would have already been there. However, it's not there, so I have to say it. Does that make sense? So when you compare graphs, you have to compare them between what's changed between the two. Okay, both of these have base 4. It says, describe the graph of the second function compared to the graph of the first function. So what does this 2 do in front? Vertical stretch by a factor of 2 about the x-axis. What's this x minus 2? What is that? Yep. Horizontal translation to right. The next page after last one.
Thank you.
You're welcome. All right. So this one, if it makes you feel better, I would move the 4 over myself. And I would make this x over 5 be 1/5 x, because that's the same thing. And then you actually get your horizontal stretch right. Or else people just stare at it and like, I don't know what this is. It's divided by 5. Divided by 5, you can bring that 5 in front and make it 1/5 x, and then everyone knows how to deal with it. So we're going to move the 4 over, and we're going to get y equals -2 once my computer catches up. Or not. I love technology. Try again. Y equals -2 to the 1 over 5x minus 4. So do I have any stretches? Yes. The base is 2. The base is 2. That didn't change. I have a -1 in front, so I don't have a vertical stretch, but I do have a horizontal stretch by a factor of what? 5. About the... Yeah. I have a reflection in the x-axis, because it's in front. And that -4 at the back, what is it? Yes. Now remember I said yesterday that the only way we can compare these is if they have the same base. We're looking at example 2, which I explained to you yesterday. So it says, explain using transformations why the graph of 1/3 x is a reflection in the y-axis of y equals 3x. The only way I can compare them is if they're both base 3 or if they're both base 1/3. It's easier to make the 1/3 be 3, so that's what I'm going to do. So I'm going to leave this one as y equals 3x, 3 to the x. Now 1/3 I can write as y equals 3 to the what? -1x. What happens when I have a negative in front of the x? It's a reflection in the y-axis. because you have a negative. You'd have to explain it in words. You'd have to say there's a reflection in the y-axis because the change is that there's a negative in front of the x, which means there's a reflection in the y-axis, right? Number 3, state the x-intercepts and y-intercepts. Whenever you hear x-intercepts, you should always think what?
Graph it.
Y equals 0. And whenever you hear y-intercept, you should think x equals 0. So for each one, we're going to do the y-intercepts first. Okay? So this is going to be y equals 2 to the 0, which is 1. So my y-intercept is at 0 and 1. This one is going to be y equals 2 times 10 to the 0, which is 2 times 1, which is 2. So I have a y-intercept of 0 and 2. This one is y equals 2 to the 10 times 0, which is 2 to the 0, which is 1. So it's a y-intercept at 0, 1. And then this one is y equals negative a half, 3/5 to the 0, which is negative a half times 1, which is negative a half. For now, because you can't solve using logs, you're going to find your x-intercepts using your calculator. Do we need to use our calculator? What's the only way we're going to get x-intercepts? When y equals 0, but what happens? Right now, unless I have some sort of translation, I have a horizontal asymptote at y equals 0. What do I need to have in order to get that asymptote to move off the x-axis so I can get x-intercepts? Because right now, I have an asymptote sitting on the x-axis, and I'm not getting any x-intercepts because I have an asymptote there, which means nothing can equal it. Yep. Yep. What am I getting? What do I have to add to it in order to get myself? What kind of transfer? Move it up or move it down. So I need to move it up or move it down in order to have x-intercepts, correct? So that means up or down means I need to have a what? Vertical translation. Do any of these have vertical translations? No. None of these have x-intercepts because none of these have any movement. So all of them have a horizontal asymptote at y equals 0, which means there's no way I'm going to have x-intercepts. I have a dashed line that means nothing exists on there. So unless I throw onto this graph a vertical translation at some point onto an exponential, I'm going to have no x-intercepts. Does that make sense? Okay. Describe these. Okay, A, we have a reflection in the y and a vertical translation 3 down. B, we'd have to change it to be 5, 2 to the negative x, because you can't compare them unless they have the same base. This one's a vertical stretch by a factor of 5 about the x. And a reflection in the y-axis. This one, you'd have y equals 6 to the negative 1 to the negative x. So it's y equals 6 to the x. So you have no change. Same graph.
Why would you ask that?
Then this one would be y equals a half x. So it's a horizontal stretch by a factor of 2 about the y-axis.
Will they ever have one of those questions like C on the diploma?
Good. Yeah. This one we will just skip for now. You could have stated it But really, I should have on here like y equals 3x is the base function, and then this is a new one, and tell me the transformations kind of thing. But it's just basic transformations. H is what goes with the horizontal translation. K is what goes with the vertical translation. A is supposed to be your vertical stretch reflection, and B is your horizontal stretch. Remember, you guys, the catch too is just like it has been the entire time. If you have like 2x plus 4, you have to take the 2 out and put x plus 2 in brackets. Remember, you have to take that horizontal stretch out if it's not in brackets. You have to do that or your horizontal translation will be wrong every single time. And that's what they do on diplomas. Remember, there will be 1 or 2 questions where you have to do that, and you won't because you don't do it on your cumes, and I've given you 2, and people continuously still don't take it out, so it's driving me batty, and this is supposed to be driving you batty with the way I'm talking, so that you know it's annoying.
What is it?
Take the horizontal stretch out when you don't take it out. What's it? Okay, which is an exponential function?
All of them. No, not A.
This one's a polynomial. What about this one?
C. Now it's fine.
Is this one good?
It's negative. Nope. Nope. Nope.
Negative base. Nope. What about this one? It's a rational. The x is in the denominator. What about this one?
No.
Yeah. Because, just wait. Why is it okay? Because this is how people write it. They write it as 3/2 to the x minus 2. That is wrong.
Really?
The only thing the x minus 2 is at to right now is what? The 3. So actually what you can do with that 2 in the bottom is you can write it as a half in front, and it's the vertical stretch. So you could rewrite this as 1/2 times 3 to the x minus 2. Do not write that as 3 over 2 because that exponent, x minus 2, is not to the 2. It's only to the 3. If you would have done that, I would be starring this and reminding yourself not to do that, which if you would have done that would be 100% of the class. And if you were not 100% of the class who would have done that, you wouldn't have known what to do with the 2. So either way, you need to star this spot and say this is what you would do. There may be like 2 people who would have done that correctly. The other ones would have put the 2 under the 3, or the other ones would have been like, I don't know what to do with the 2. I get that it doesn't go with it, but I don't know what to do with it. So that's kind of not good either. So we're going to star it. We're going to come back to it. If you want to borrow a stinky highlighter or a good smelling highlighter, highlight it. If you want to borrow a non-stinky highlighter, go ahead, highlight it.
I was wearing a stinky highlighter.
Top drawer. Okay. Which equation determines okay. Which equation determines the asymptote? Shh. I take away the +1 at the back. What's my asymptote? Y equals 0. I add the +1 at the back. What's my asymptote? 1. Didn't have to put in my calculator. Didn't have to do anything. I had a horizontal asymptote at 0. I moved it 1 up. So it's not at y equals 0 anymore. It's at y equals 1. Super, super easy concept. Super concept that everyone forgets about on the test. Starts plugging in. I put a whole bunch of... Because I can put letters in all these spots. I can go... Pay attention. I can go y equals a to the b minus 2 plus 1. And you're all freaking out because there's a whole bunch of letters. It doesn't matter what the other letters are. The only thing that moves your horizontal asymptote is the vertical at the back. Once I put in logs, you forget that. So remember it. Lock it in your memory for a long period of time. Okay. Consider the function. Yeah. No, because your asymptote's a horizontal line, it wouldn't make it wider and narrower. So the only thing that affects the asymptote is the vertical translation. Now it would affect the graph though. Vertical stretches would affect the graph for sure. It just wouldn't change the asymptote. Okay. Also, like a reflection would affect the graph, but it wouldn't affect the asymptote. Okay. Example 7. Consider the function f of x equals 5 to the x plus 4 plus plus 3. Determine the domain and range. What's the domain of every exponential function unless it's a word problem? Wow, yes. Okay. The domain is negative infinity to positive infinity, or in set notation, set builder notation, it's x such that x is now in the reals. Unless it's a word problem. If it's a word problem, it might be limited. Like if the x was time, let's say, you wouldn't have negatives, right? So it'd be x is greater than or equal to 0. Now the range. This graph, the normal exponential graph, has a range of y is greater than 0. What's the only thing that can change your range? Well, moving the asymptote would change your range. How do I move my asymptote? Y translation, vertical translation. What else would change my range? My range is normal on a normal exponential graph is y is greater than 0, right?
Yes.
What would cause it to be less than? In the x-axis. So I would either, the only way my domain is going to change is if I have a negative in front of my a value, right? And I have a vertical translation. So let's look at this. I have a vertical translation 3 up. Do I have a negative in front of the base of 5? No. So it's going to be greater because I don't have a negative in front. But it's going to be greater than what, this case? 3. Not equal to, because that's where the asymptote is. And in interval notation, be greater than 3. So 3 to positive infinity. Round brackets because it's not equal to either infinity nor 3. The equation of the asymptote, it's a horizontal asymptote at y equals 3. X-intercepts and y-intercepts. In this case, do I have any x-intercepts? The vertical translation exists, so there's a chance I have x-intercepts. Do I have any? No, because I still have a graph that's completely above what now? 3. It's completely above 3. So if my whole graph is above 3, is it crossing the x-axis at all? Had I had a reflection in the x-axis, would I have x-intercepts? Yes, because my graph would be reflected down.
Oh, dirty.
Ah, light bulb moments. Wonderful. So if there was a reflection in the x-axis and I moved up 3, I'd move up 3, and instead of my graph being like this, it's now like this. So it's, yes?
Yeah, but you do the reflection first. Do the reflection first.
Sure. I'll do the reflection first. Now what am I going to do with it?
Plus 3, so 3 up.
Oh, prove my point correctly. Bam, bam, bam.
Yeah, we set you up.
Your range would have been down. All right. He set me up. So there's
That could be an extra mark.
you two asked for totally different separate things. He was wondering if I got credit for this, and you want credit for it. Okay, no x-intercepts. Because it's completely above, it's 3, the y is 3, is greater than 3, sorry, not equal to 3. X-intercept, there's none. Y-intercept, I fill in 0 for x, so I get 5. No. No. Y equals 5 to the 4, so am I learning. Patience. It's a great thing. Okay, what's 5 to the 4?
Oh, that's a good question.
What's 125 times 5? 625 plus 3, 628?
Yeah.
Is it?
I don't know. Hold on.
628.
625.
Plus 3, which is 628. So it's 0 and 628. See, doesn't it make you feel like transformations are so much? Tally's like, I mean, Frederica, you're not allowed to say names on here, so I'm going to call you guys random names. Frederica,
It's actually legal to do that.
I guess so. Frederica does not agree with me. So when I'm calling you guys out, I'm going to call you out with random names that don't exist in this school. I don't think there's a Frederica. Juan Pablo. Yeah. There you go.